All right, let's rock and roll and do section 2, part B of the 2023 BC FRQs. Per usual, 4 questions, 15 minutes a question. You get an hour, no calculator. Number 3 was a crossover, so the AB and the BC students had to do this one. And again, you can go into my YouTube channel, and if you need to kind of slowly go through this one, watch that video, please. Number 4 was another crossover between the AB and the BC. So both sets of students took this one. And you can watch me go over that one if you need to in my YouTube channel. Number 5. So this is the one we really need to wrap our heads around. So this is the exclusive BC question in this section. Section 2, part B. Number 5 looks to me like we have a shaded region. They're giving me some information. They want me to find the area of the shaded region. They want me to evaluate an improper integral. And then they want me to integrate h. And it looks to me like this is where they're going to make me do my integration by parts. All right, so let's start from scratch. F and G are shown. The nice part is without a calculator, they're restricting me to whole numbers. I'm good with that. So we're going from 0 to 3. My g of x is 12 over 3 plus x. And I usually like to write things into the picture they're giving me or the diagram they're giving me, just to aid me in what I'm looking at. But that's for x is greater than or equal to 0. They're telling me I have a twice differentiable function f. I don't know if I need that, but that's a good thing to know in terms of continuity, which is not explicitly given. So they're not giving me that, but they are giving me a value on f when x is 3, y is 2. And they're also giving me the area under the curve to the x-axis from 0 to 3 for f. And that's a good thing. All right, so part A. Find the area of the shaded region enclosed by f and g. All right, again, I always like to use their words. So I'm going to start over here, and I'm going to write area of shaded region. Equals. All right, I want to integrate from 0 to 3. It's just going to be what? Area between curves, top minus bottom. So I'm going to use a parenthesis because I don't know what f of x is, but that's my top function for that region. And then I'm going to subtract g, which is, now this isn't a calculator portion, so I'm writing this out. So that's minus 12 over 3 plus x dx. All right, so I should get a point, right, just for setting that up. But now, again, without calculator, we got to show that we know how to do this by hand. And that's kind of how, over the years, the College Board has gotten a little more challenging in terms of the kind of work they're going to require of you on FRQs. And usually I like to throw in some fractional things at you also at some point. But let's integrate this. Now, always be aware of what they gave us. So the integral from 0 to 3 of f of x is 10. And then I'm going to subtract, and I'm going to leave the negative outside here. And you're like, you could put it in if you wanted to. But this is in the form of what? 1 over u with no adjustment, right? Because the integral of 1 over u is ln of u. And you should be well versed in substitution. So that integral is 12 natural log of the absolute value of 3 plus x. Then I'm going to go from 0 to 3. And I'm going to keep writing this all in one line as I go. And I'm going to do FTC of the second part of this expression. So 10 minus parenthesis. When I plug in 3, I get 12 ln of 6 Then I'm going to subtract plugging in 0, which gives me 12 ln of 3. So my thought is I'm just going to keep running down with my work. I can factor out a negative 12. That'll give me what? Ln of 6 minus ln of 3. Because if well, I guess maybe it's best to show it as negative 12 ln of 6 plus 12 ln of 3, just so that you don't mess this up. So if I factor out a negative 12, right, I'll get my ln of 6 minus ln of 3. I guess it would have shown itself that way anyway. I can use log simplification properties, and that just becomes ln of parentheses 6 over 3, which becomes ln of 2. Maybe some of you would stop here. I don't know. I mean, I haven't graded one of these before, but I would try to simplify it and use all the rules I know from all the previous math classes that I know. But that would simplify there. And some of you could even bring the 12 up into here, but that wouldn't be simplifying the log. That's the simplified log. All right, evaluate the improper integral from 0 to infinity of g of x quantity squared dx, or show that the interval diverges. All right, so you need to have the fundamentals for dealing with a limit. In this case, the top limit of my integrand is infinity. So how do you deal with that? Well, you substitute in and say let the limit, or find the limit as b approaches infinity of the integral from 0 to b. Now this is where I would substitute everything in. Now I'm going to square my g, which isn't that hard to do without doing much work. So that'd be what? 144 all over parenthesis 3 plus x squared dx. Now this would give me a substitution. I guess it's probably best to maybe write this out. We're going to let u equal 3 plus x. My du would equal dx, which gives me what? The integral of 144 all over u squared du. So that would give me what? 144u to the negative 2 becomes 144u to the negative 1 divided by negative 1, which would give me negative 144 over u. But my u is 3 plus x. I guess you could have done this in your head. I just felt it was probably best to do it so I don't make a mistake. So equals the limit as b approaches infinity. Now I'm going to use FTC, so the integral is going to be what? Negative 144 all over 3 plus x from 0 to b. Now I'm going to plug in my b, so that'll give me limit as b approaches infinity, parenthesis, negative 144 all over 3 plus b minus 144 over 3. So I need to apply the limit to this. And again, the principles of limits, or the fundamentals, are that you plug in infinity, right, and see what happens. That would just give you 0, right, because the bottom is growing faster than the top. That's a constant, so the limit of a constant is a constant. And you can divide this out in your head or off on the side if you want. 3 goes into 14 4 times. Carry down the 2 and the 4. It goes into it 8 times. but I'm sorry. I want to subtract that in my FTC. Kind of getting ahead of myself a little bit. But that would be plugging in B minus plugging in 0. Negative, negative would give me a positive 48. And like I said, I'll find the mistakes. No one's perfect, nor do you have to be. What do you got to get, about a 70 out of 108 on the BC? Maybe 75 to be comfortable knowing you're going to have a 5 on this. So there's a lot of opportunities for you to make mistakes, but try not to. You should have plenty of time to kind of look things over. Let h be the function given by this. So we have a product of x times f prime. Find the value of the integral from 0 to 3 of h of x dx. Okay. I'll substitute in the integral from 0 to 3 of x times f prime of x dx equals, and again, I don't know how you were taught integration by parts. I taught my students just function notation. So f and g prime. So I know I want my f to be x because when I trade down to another integral, I want it to take the derivative of x down to a 1. My g prime then would be f prime of x, which integrates to g, which is f of x. And again, some of you might say, well, that's a little confusing. You're using f and into this one. I don't know. It just depends how you learned it. It's just f times g, which would be x times f of x. Now remember, this is going to be the fundamental theorem of calculus. So I got to plug in, or use my FTC, plugging in 3 minus plugging in 0. But I'm not ready to do that here because I needed to trade this. So that's minus the integral from 0 to 3 of f prime times g, which is f of x. So that gives me, let's look at this carefully. That gives me 3 times f of 3 minus 0, because when I plug in 0 for x, it's just going to give me a 0. But I know the integral from 0 to 3 is 10 for f, so they gave me that. Well, what is 3 times f of 3? Well, f of 3, and lo and behold, there's where it came into play, is 2. So 2 times 3 is 6, minus 10 is negative 4. Mistakes were made. I was talking so fast that I didn't put the little equal sign right here. It is fixed. Sorry about that. Not too bad. I don't mind that.